Hey, sixth graders, as we wrap up our unit on rock transformations, we are going to do a quick review and then some information about what's expected of your project here coming up. So remember that the question that we are trying to answer in this unit is how do rocks form and change? So how do we get rocks, right? How do they become rocks and form in a certain way? And then how can they change? And we looked at that by talking about the rock transformation process. So we know that there were two types of rock materials that really helped us understand how we got these rocks, and that was sediment and magma. And when we used the rock transformation simulation, we were able to create sediment by using energy from the sun. So up here, it said, where did the energy come from? So the energy came from the sun, and we used that by weathering. So we had rain come down, and it broke down this huge rock into smaller pieces of sediment, which then eroded, and through the process of erosion, they moved down into the river or into the ocean, whatever body of water this is, and then over millions of years, they were able to settle down and compact together and cement together and into a sedimentary rock. So we know that sedimentary rocks get energy from the sun. We have weathering, erosion with sediment material and compaction, and then we get a sedimentary rock. Similarly, we also talked about magma. So we talked about the rock material magma, and before we have the magma, we have mantle rock. So if you remember in the simulation, this is our mantle rock, and we used the energy from Earth's interior. It says Earth's interior right here. We used the energy from Earth's interior to melt the mantle rock, which is what gave us this magma. So we start with a rock, and then we melt and get our magma. So our magma rises. It can either rise inside into the rocks that are there, or it can rise to the surface. And when it cools, then we get an igneous rock. So again, we have energy from Earth's interior. We have melting, magma, cooling, and then the igneous rock. The superposition is what tells us how old rocks are. So we know that our youngest rocks are at the top and our oldest rocks are at the bottom, and that rocks settle in a horizontal position. So over time, new layers are added to them, right? We can see each of these layers that happens at a different time, just like when we lined up in the classroom and from youngest to oldest, and we could say that the oldest people were at the bottom and the youngest people were at the top, and each person was born at a different time, and we're all adding to each other to create our class formation. So our youngest are at the top, our oldest are at the bottom. And sometimes we have cross-cutting rocks. So again, we have this rock here that cuts across this sedimentary rock that is deposited in a horizontal way, and this is coming in across it, and this rock is going to be newer than the rocks around it. So excuse me. I thought there was another video on cross-cutting. Let's see if we can go back. Okay, so being able to explain that cross-cutting concept is going to be really important. Again, you can go back into lesson 3.1 if you have some really burning questions about that. All right, this is the simulation that really explained everything that we did this year. I think I have this I thought I had it going in fast mode, but I can push it out. Hold on. There. Okay, so when we're using this simulation, it's important that we look up here at the current process and the duration, and knowing that these things take millions of years to happen, that these processes take millions and thousands of years to happen. So sediment comes, it's compacted together, it's moving, it's cemented together, and then we get different layers of sedimentary rock, but it takes lots and lots and lots of time. It doesn't just happen overnight like with our Jolly Ranchers. Similarly, with our magma, it takes time to rise, it takes time to cool, it takes time to melt. So we, again, if we look at our Earth's, if we look at our our simulation, we can look where we get our energy from. So we get our energy from the sun. We also get energy from Earth's interior, and the processes that happen in there are weathering, and the processes that happen in here are cooling, melting. And then after all of that, we can have these happen below the surface and at the surface, and our plates can move just like we learned about with the Grand Canyon. And then after all of that happens, then we have compaction, and I'm not going to write that. It's going to take too long. Or I could type it. We have compaction, cementing, and then we would have cooling for the magma. Again, in your presentations, I'm going to be looking for understanding of all of these concepts. So not just you being able to put them on a piece of paper, but to really show that you understand them and explain them. So to do those kinds of the things that I want you to show you understanding of is sedimentary rocks and igneous rocks. So what are they? What rock materials do make up of them? What can we learn from them? And then the transformation processes, so that is including energy, so that means weathering, erosion, melting, magma, rising, cooling, energy, and all of those things. Again, I just want to reiterate that it's not just putting these things on paper, but really showing that you understand it. So what question are you asking initially to show that you understand it? You thinking of that initial question, how do rocks form and change, or what happened to these rocks in this particular place, or how do we get these rocks in a particular place, is really going to help you develop and form that project in a way that shows you understand, rather than just putting all of this on paper. If you have any questions, feel free to send me a Schoology message. I can answer those, and I hope that you enjoy working on this project today and tomorrow, and as we finish it up. Remember, today is a great day to learn. Happy learning!